People come here to the Smokies during a particular 2 weeks in June to see synchronous fireflies. And this year, that happened in May, well before the event that was going to start on June the 7th. So when people actually got here on the 7th, not only had the peak passed, but the firefly display was completely finished. Can we say that was because of climate change? No, but if we look at the trend over the years, we can see that some of these, over the years, the events are occurring, earlier than they used to.
Phenology is the time of year that certain events happen in the biological world. So when things flower and when they turn to fruit and when the leaves turn green on a plant, come out and then turn color perhaps in fall, those are all phenological events. When migratory birds come back from the tropics and start singing, set up territories, when they have their nests and when they depart, those are all phenological events.
It can be at the community level or at species level. And this is important because there's a lot of synchrony between species and communities. And if climate change happens too rapidly or if other issues involving climate, temperature and moisture, it could lead to impacts which we need to be aware of. Phenology in this park really started with Arthur Stupka, who was a 1938 appointee to this park as a naturalist and later biologist. And he started recording times when various plants bloomed in different sites. And I don't mean a few times. I mean, he made 18,000 observations having to do with all sorts of different things, and many of those are based on phenology. And we have that in a database that we can now search. And that gives us a good basis for looking at changes, particularly in plants and arrival of birds. We've had plots out now for 10 years, off and on, looking at the same exact 4-meter square area, 3 plots in a site, and then multiple sites at different elevations. And there we actually do counts of individual flowers in full bloom. In some cases, the same species on an elevational transect.
One other thing that we have been recording at the Great Smoky Mountains Institute at Tremont, over on the Tennessee side of the park, the teachers there and the students have been recording the first time they hear wood frogs sing, or the first time they see such and such a plant bloom, or the first time they see a dragonfly. And many of those species have been showing earlier phenology over the past couple of decades. The problem with that kind of data, it's useful, but we want to collect data at very specific locations, repeating them over and over again, so that we can figure out not just the first one, but when the peak arrival is, or when the peak bloom is. You have to go out and you have to follow an individual tree or an individual set of plants, or go to the same place and listen for birds over the period of time that you might expect them to come back. But that's data for just 1 year. So in order to look for trends, is it getting earlier? Are they coming later? You would need to go back and do the same thing with the same plants, the same site, over and over again for several years. And there's a lot of variation from 1 year to the next. So you would want to have several years to average it out to see a trend.
So the question of identifying what's causing changes in phenology that people are observing over long periods of time, especially in one particular location, is a tricky question, because first you have to be able to establish that temperature changes or changes in precipitation are what's driving that, and then you have to understand what's driving those changes in temperature or precipitation at that one place. Because in a lot of different places, temperature change can be because of urbanization or deforestation, and that can cause warming of an environment. Or if you go from agricultural environment to primarily a forested environment, you can get cooling that's just caused by local effects rather than human-caused global climate change. But what allows us to understand that phenological shifts more broadly are attributed to climate change is that we're seeing similar patterns in lots of different locations across the world, so that local climate change can't be the driver of all of them.
I think of the Smokies like a giant English muffin, and we have all these little nooks and crannies. And you know, when you toast an English muffin, it doesn't brown evenly. Well, the Smokies is like that with temperature. So to really sample in the Smokies, you need to really get into all those nooks and crannies, and we just don't have enough park staff to do that. So with citizen scientists and carefully planned out locations of plots, we can actually get people to adopt a plot and go in and help us to collect this data about each little nook and cranny that we're interested in, that we just couldn't do as park rangers. So again, we're hoping that people will develop a relationship and actually start to notice changes that we as park staff might not see, because they're out there maybe on a weekly basis checking the same spot. They're going to really get to know that location and document those changes as opposed to just be anecdotal changes.
7.2.
7.2.
We got it, yes! That one. We caught one!
The reason why citizen science is such a great tool, for one, people like contributing. They like feeling like they're helping. You know, if you give people an opportunity to help collect data that you truly are using, and that's kind of the key. It's not citizen science if that data never gets put into a database, never gets looked at. But if you're truly using that data and people have a way to contribute to that data, they feel good about it, they like doing it, you know, they get that personal connection both with the park and with whatever it is they're studying, and it just, it's a total win-win situation. But we're going to be tracking this tree over time.
Okay.
So for this year, it's a 5.
Yeah.
I feel that the phenology study in particular has made the issue of climate change more accessible because it's a way for people to relate to it personally. You know, people around here, for instance, are tuned in to spring wildflowers and the leaves changing in the fall because our economy is really tied to the tourism that revolves around some of those events. So there are things that people notice anyway, but if we're letting them know about some of these possible mismatches, it's not just that the flowers are blooming 2 weeks earlier, but there's this whole kind of trickle-down effect that you get if flowers bloom earlier and the pollinators aren't there, and the birds who eat those pollinators, and you know, these things that can go out of synchronicity and out of whack, that there's this whole chain of events. And phenology is just beautiful for illustrating that, and it's happening now. It's not happening conceptually 10 years or 20 years in the future.
Climate change is real, it's happening around the world today. Its effects are measured, seen, and felt in many different ways. And no matter what we'd like to hope, pretend, or just ignore, we've got lots to learn and do. Hey, now that's what this song is for.